All right, so here in this video, I will be talking about volume of solid. This is number 2 in the integration by parts. Okay, now the function here is f of x equals e to the negative x, and this one right here is x equal to ln of 2. So what are we doing here? We are going to take this region right here and have it revolve about the y-axis. So I'm going to have this other side looking like this, right? And it becomes some sort of like three-dimensional shape like that, right? Now, because I just drew that, my brain is thinking, oh, hey, I can have a cylinder and a cone looking shape, right? Now, if I was to go that route, I would say volume equals to a cylinder plus a conical looking shape like that, right? Now, the cylinder has radius of ln of 2, because the radius would go from here to here, right? So radius would go from here to here, and the height would be 1/2. So I would have here my my volume is pi r square h, pi ln of 2 square multiplied by h is 1/2, so I can just divide it by 1/2, right? By 2 right there. And then this part right here would be the integral from, I'm going to go ahead and slice it this way by volume by slicing, delta y, right? So this would be from 1/2 to 1, okay, delta y. The cross-section is a circle, right? And the radius go from here to here, which would just be the x value. And from here, you would say x is equal to negative ln of y, right? So then that would be pi r negative ln of y, right? So pi r square multiplied by how thick? Pi ln of y square dy, and the negative doesn't really matter. I squared, it becomes a positive, right? Now that if I want to do that using volume by slicing, and then you will see that this right here is something that we have seen in the previous video, right? So that's kind of boring doing the same thing over again. So what I want to do really is to go ahead and do this not by slicing, not by breaking them into a cone and a cylinder, but to do this by shell. Okay, so I'm going to go ahead and do this by shell, volume by shell. So this part is right here is volume by slicing. Okay, I'm going to now do this volume by shell. All right, so in order to do volume by shell here, I am going to take one rectangular strip, revolve it, right? Revolve it and get a cylindrical shell, right? Get a cylindrical shell where the thickness is delta x, okay? And the height would be my e to the negative x is my height, right? And I am going to go from 0 to ln of 2, okay? Now when I take this cylindrical shell and break it apart or open it up, it becomes a rectangular solid, right? This thickness is delta x. The height is e to the negative x. And the length of this is the circumference of this circle, and that would be 2 pi x. Okay, because this right here, the radius is the x value. Okay, so then the volume by shell is volume is equal to the integral from 0 to ln of 2 pi x times e to the negative x dx. Okay, so let's write that neatly here. And this is multiplication, right? Okay, so that right there will require integration by parts. Okay, I'm gonna let the 2 pi, the constant, be on the outside. So volume equals 2 pi. Okay, and we would say the integral of x e to the negative x dx right there. And here is how we are going to go and do that. We're going to take the u to be, remember, integral of u dv is equal to u times v minus integral of v du, right? So let u be something that you can take the derivative of, and let v be dv be something that you can take the integral of. Now here is a lesson to learn in this particular video. Besides the fact that we want to do this by shell, it's probably looking a little bit simpler than by slicing. Okay, but that's probably is an opinion. But here in this concept of integration by parts, the lesson to learn here is what to let u be and what to let dv be. Okay, so if I was to, let's just for example here, if I was just take a look to let u be e to the negative x, because I say, oh, I can totally take the derivative of de to the negative x, so du is negative e to the negative x, right? And if I was to let dv be x dx, then my v would be x squared over 2. Okay, now when I do this integration by part, u times v, that would be x squared over 2 e to the negative x minus the integral of v du, which is x squared over 2 e to the negative x dx. I mean, look at what I get. Something even more complicated than my original integral, right? So if you are going down this road like this, you would say, oh, hey, maybe we want to go back. And this is why we use a pencil in math. We go back and we erase. And we say, let's try the other way around. Okay, so let now u be x and dv be e to the negative x dx. Okay, so now du would just be 1 dx, and v would be negative e to the negative x. Okay, so the integral here will be, if we go ahead and write this down, we would say volume is equal to 2 pi in the front, right? And then here we would have u times v, which would be negative x e to the negative x minus the integral of v du negative e to the negative x dx. Okay, and don't forget we're kind of ignoring the limit of integration there, and we're gonna go ahead and put that in at the end, right? So volume is equal to 2 pi, and here negative x e to the negative x minus is going to be a plus right there. The integral of e to the negative x dx is negative e to the x, and we are evaluating that from 0 to ln of 2. Okay, so now we can go ahead and plug in our limit of integration so that we can do the calculation for volume. Okay, so let's take a look. 2 pi volume, 2 pi in the front here, right? And when I plug in ln of 2, I have negative ln of 2 multiplied by e to the negative ln of 2 minus e to the ln of 2. Okay, that minus, plug in 0, I have e to the 0 power is 1 times 0 is 0, minus 0, plug into x, e to the 0 power is 1. Okay, now this kind of look complicated, but don't worry, we have a trick. We have a trick here. Let's take a look. Okay, e to the negative ln of 2. Negative log, right? The negative is negative 1 right here. You can go ahead, put that on top as an exponent. That would be e to the ln of 2 to the negative 1, which is 1/2. E undoes ln, you get 1/2. Okay, so that right here is, this right here is 1/2. So that becomes negative ln of 2 over 2. Okay, and here, we're missing the negative sign right there, right? So this is negative. Okay, so again, this right here is negative minus 1/2 plus 1, and here is 2 pi in the front. Okay, so we are looking at this, that's a half, right? So that is 2 pi times 2 on the denominator there, 1/2, that would be 1 minus ln 2. This cancel with that, so that will just be volume is equal to pi times 1 minus ln of 2. Okay, throw that into your calculator. Okay, go ahead and throw that into your calculator. Ooh, what just happened here? Okay, once you have it into your calculator, the volume is approximately 0.964 cubic unit.